Okay.
All right, we're talking about thermodynamics now. So one of the first things we're going to do is we're going to change different units of energy. So the first one says, how is energy calculated? And we have 1 capital calorie. So capital is how we measure our food. So when you look on the back of your food label and it says you have 200 calories, that's capital C. And every capital C there is 1,000 little calories. And there are also in 1 little calorie, there's 4.184 joules. So here's our example. How many joules are in 170 capital calories?
So we start off, it's just like stoichiometry, you're just trying to cancel out your units. Okay, so you have 170 capital C's. We need to get rid of our capital C, so we put those on the bottom. And that's 1,000 little calories. And then 1 little calorie is equal to 4.184 joules. And everything cancels out. We're left with joules, which is what the question asked for. Sorry, let's identify what we were given and everything else. And we multiply across the top and divide by the bottom. That's 711,280 joules. And yes, Yasmin, that's how many joules is in your yogurt that you were eating the other day. Okay, another way that we do it is we use our Q equals MC delta T. This is just a bullet here. That's not a minus. That's a bullet. Q is your heat. Your C is your specific heat capacity. M is your mass. And delta T is your change in temperature, which is your final temperature minus your initial temperature. And the practice problem that we have is if we have 3.44 grams of ethanol, and it goes from 25 degrees to 78.8 degrees, we want to know how much heat is absorbed. So we're solving for our Q up here. That's what we want to know. We're given everything else.
So our formula is Q equals MC delta T. We're looking for Q. Our mass of the problem was 34.4 grams. You're going to multiply that times the specific heat, which they gave you as 2.44. And you're going to multiply that times the change in temperature, which is T final minus T initial. So it ended at 78.8. It began at 25. So the difference in that is 53.8. So that 53.8 is our change in temperature. Multiply all 3 of those together. You get 4,515.76 joules.
And whenever we're doing Q, that is a 4. Whenever you're doing Q, that unit will always be joules. Your unit for mass is grams. In this particular part of the unit, our temperatures do not have to be in Kelvin. We do work with degrees Celsius, so you want to make sure that you don't start trying to combine the 2 parts of the units. That's why we end up splitting it in half. And specific heat capacity is always joules per gram degrees Celsius. And the last thing that we're going to be working with is how we use our Q equals MC delta T in the lab. We're able to figure out specific heat capacity, and that's what you're doing with your gizmo. Add different things based on how it affects water. So we have 50 grams of a metal. It starts out at 115 degrees, so that's our T initial of our metal. We have 125 grams of our water, and our T initial of our water is 25.6, and our final is 29.3, and that's actually the final temperature for both substances, the water and the metal. And we're going to find a specific heat capacity. So what you can do in that is
you're going to set the 2 things equal. So however much heat is lost by the metal, it's going to be the same amount of heat is gained by the water, because you're sticking that hot metal into that water. So you're going to set your 2 Q values equal to each other. So for the metal, we know that the mass is 50 grams. We don't know the specific heat. That's what we're looking for. And our change in temperature is, it started at 115, but it ended up at 29.3. So it was 29.3 minus 115, which gave me, I didn't calculate it.
We'll work on it. So notice that we have this negative sign in front of the Q. That's because we want this to end up becoming a positive number.
It's a negative 85.7. On the other side is the water, so we know that we have 125 grams of water. The specific heat of water is 4.184.
And that's an always, that's a constant, learn it.
And our temperature in the water starts out at 25.6 and ends up at 29.3, which was 2.8. From here, it's just algebra. You're solving for that C.
And it ends up being 0.34. Remember the unit for your specific heat capacity is joules per gram degrees Celsius. And that's the answer. And normally, we could even ask you, give you a list of metals and go, so what metal is this? And we'll actually do that in the gizmo. You're going to be learning a lot of the math in the gizmo, just practicing and making sure you're doing it well. We'll see you in class. Hope you had a great weekend.